Welcome to 71st lecture of circuit analysis. We are studying transient analysis of circuits, and in last lecture we studied some characteristics of capacitor when we have sudden variations in applied voltage or applied current, right? In fact, in applied sources. In last lecture we studied that current through capacitor, I sub C of t is C times this V sub C of t. It's based on this time derivative. The current through capacitor is based on the voltage across capacitor, its time derivative times its capacitance. And we also studied that this expression can be written in reverse, that the voltage across capacitor can be computed using the current flowing through it by integrating it over time from minus infinity to t and dividing by the capacitance. Right. This second expression, equation number 2, if this is equation number 2 and this is equation number 1, this equation number 2 tells us that the voltage across capacitor is based on a derivative term. This means that voltage across the capacitor, it is based on an integral term, a term that involves a time integral. So this time integral term cannot change all of a sudden. So the voltage drop across capacitor cannot change. If we have certain variation in applied voltage, like for example, we have here. In this case, in this simple circuit, we have this DC voltage source, a switch K that is open initially, and we are going to close it at time t is equal to 0, an R and a C. And switch K is closed at time t is equal to 0. So now we have two different important time values, time t is equal to 0 plus and 0 minus. 0 plus means that just after closing the switch, just after we have closed the switch, and t is equal to 0 minus means just before closing the switch. So let's see the transient behavior of this RC circuit, that is based on the transient behavior of this circuit will be decided by the capacitor. So at time t is equal to 0, we don't have any current because the switch is open and there is no current flowing. And of course, the voltage drop across resistor and across capacitor will also be 0. What happens at time is equal to 0 plus? Time is equal to 0 plus means that we have just closed the switch. And just after we have closed the switch, what happens to the current and two voltages across resistor and across capacitor? Since the voltage drop across capacitor is based on an integral term, it cannot change suddenly. So it becomes short. The voltage drop across resistor is 0 at time t is equal to 0 plus the time just after we have closed the switch. So if this is replaced with a short circuit, we have only this V and R in the circuit, and according to Ohm's law, the current would be V divided by R. So V across R, this voltage, the voltage drop across resistor, can be computed as the current flowing through the circuit times the value of resistance, I of 0 times R. So it comes out to be the whole voltage appears across this R. Why? Because this capacitor is replaced with a short circuit just after closing the switch, but it is not always. After the time passes, so V of 0 plus is 0. After the time passes, some voltage starts developing across this capacitor. According to the current through this capacitor is governed by this formula, and the voltage across capacitor is governed by this formula. So what is the voltage drop across capacitor after a very long time and for all values of t? That is important. So that will be the topic of this third part of the course, the transient analysis. And this calculation, computing I of t and V of t, I sub c of t and V sub c of t for all values of t, requires a bit of mathematics, and it requires solution of differential equations that we have studied in mathematics course. And that important solution will be discussed in our upcoming lectures after we have studied this transient behavior just after opening or just after closing the switch for inductors and capacitors both. So in maybe in two after 2 or 3 lectures we will be discussing this differential equation based of solution to compute I of t, I sub c of t and v sub c of t for all different values of t. For the sake of this lecture, we have to study the behavior of this R series RC circuit for certain variations in voltages at time t is equal to 0 minus and 0 plus. And for all as I have told before, the expression for all values of t will be discussed in our upcoming lectures based on differential equations. That's all for this lecture. We'll continue studying more about transient circuits in our upcoming lectures. Thank you.